Welcome to Vision Plus and welcome back to this senior form mathematics on complex numbers. We are now doing example 1 under the Argand diagram. Example 1 says that we are given three complex numbers Z1, Z2 and Z3. And the question says that we need to represent the following on an Argand diagram. Part A is saying represent Z1 on an Argand diagram. So the solution is part A representing Z1 on the Argand diagram. What do you need to do? You just need to draw the complex plane first. And remember, Z1 is given there as 7 plus 4i. So you come and draw the complex plane. And then you name the axis. For it to be a complex plane, since here you have Z1, you can just say this is the real axis. Or in some cases, you can just say it is the real part of Z, real Z in that format. But if you say real axis, there's no offense. Then here you write imaginary axis. And then you come. Remember, the complex number has two parts. It has the real part and the imaginary part. The part containing I is the imaginary part. The part without I is the real part. That means on the real part here, we need to locate 7. Our representation on the Argand diagram is not accurate. It is not accurate. So it is just an illustration. It is not accurate. So you just come and you mark like the same sizes. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. This scale now contains 7. This is 7. And then you can mark the same here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. But remember, the numbers on this side are negative. This is negative, this is negative, this is negative, this is negative. And then you also come and mark up here 1, 2, 3, 4, 5, 6, something like that. 1, 2, 3, 4, 5, 6. And then you also come and mark down here 1, 2, 3, 4, 5, 6. Negative 1, negative 2, 3, 4, 5, 6. This side also the numbers are negative. Now we have drawn our axis, which is the complex plane, and we have marked. We have put the scale. Remember, let me repeat, the Argand diagram is not accurate. You do not need to even use a graph paper. But if you use a graph paper, it is going to be very accurate. But here, we just illustrate or represent, not necessarily accurately. Now, on the real axis, we are supposed to locate 7. So we come and look for 7. 7 is here. If this is 6, this is 7, and then 8. This is our 7 here. I do not want my work to be congested, but there is no sin or any issue that if you are numbering 1, 2, 3, 4, 5, 6 like that. So this is 7. And then on the imaginary axis, which is the vertical line, we'll locate 4. You need to have your ruler so that you are a little perfect, so that your representation is reasonable. So here you're going to draw just a dotted line, not a solid line. It's just a guiding line. That okay, this 4 moves in that format, something like that. And then also this 7 goes up straight, something approximately straight. It doesn't have to be perfect, something like that. That's a line. So you estimate that okay, 7 and 4 are going to meet somewhere here. This is where they're going to meet. So you draw a straight line from the origin. Always you must be drawing from the origin up to that point. You draw a straight line from the origin up to that point. And then remember, we said it is a vector quantity. It has direction. So we say this is the direction of the complex number. Put an arrow at the top. And then you just mark it and say, this is my complex number Z1. And then you leave it like this. This is the Argand diagram where we have represented Z1. Now going to Z2, we shall follow the same method. That is part B. Part B says that we need to represent Z2, and Z2 is given as 2 minus 6 times. Always, as long as you are representing on the Argand diagram, you start by drawing the axis. You get marks for the axis. Let me use my straight hand to be straight for this. This is the real axis. Always name the axis. If you don't name the axis, some teachers will cross the whole word. This is the imaginary axis. After drawing the axis, this is now the complex plane, but we need an Argand diagram. So we must show Z2 on the complex plane. Now, if you look at this number, we have 2 and 6. So just come and label the axis. For the horizontal line, you can just say, since here we need 2, you can just say, here I'm going to have 1. I need more space. Don't congest your work. So I can say this is 1, 2, 3. This is 1, 2, 3. But this one must be a continuous number. This is 1, 2, 3, negative 1, negative 2, negative 3. Because you know the normal Cartesian plane has 4 quadrants. We have the positive x-axis and negative x-axis, positive y-axis and the negative y-axis. So in this case, we have the positive real axis and the negative real axis, positive imaginary axis and negative imaginary axis. So we have marked, because here our real axis we need 2, which we have here, but on the imaginary axis we shall need to locate negative 6. That means our scale should be smaller. Like we use shorter distances: 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Negative 1, 2, negative 3, 4, 5, 6, 7, even 8. Negative 1, negative 2, negative 3, negative 4, negative 6, and then negative 8. Yes. So after labeling the axis, and you have made sure that it will accommodate the numbers you have there, because on the imaginary axis you have seen I've gone as far as even negative 8, but on the real axis, since here we have 2, I have just made the one that will accommodate the values that I have. Now from here, what do? You just need to get the point of intersection of 2 and negative 6. Remember, 2 is the real part of the complex number, which is here. And then the imaginary part of the complex number, which is the coefficient of I, is negative 6. So we shall take these 2, and then we'll look for negative 6 on the vertical axis. And the negative 6 is here. That means this line will come in straight down here. And then this is where now negative 6 will also go. So they will meet somewhere here. This is positive 2 and negative 6. So you draw a straight line from the origin up to that point of intersection of 2 and negative 6. A straight line in that format. And then with an arrow at the top. And then you just mark it and say, this is my Z2. And therefore, that is the complete Argand diagram representing the complex number Z2. Finally, going to part C. Part C is telling us to find Z3. Please pause the video and try it out. Now Z3, first go back and check. What is Z3? Z3 is negative I minus 1. So what is the first step? Start by drawing your complex plane. Say this is my real axis, and then this is my imaginary axis. Then if you look at the numbers, I'm seeing a negative 1 coefficient of y and negative 1 for the real part. So these numbers are small. So you can just say log 1, maybe 2. Log 1, 2. 1, 2. 1, 2. Don't congest your work. And by now I know you know how to plot. The distancing between the points on the real axis should be equal, and the one on the imaginary side should be equal. The one for the real side may be different from the one of the imaginary side. Yes, you know that. Explaining will take us more time. Now you have here 1, 2, 1, 2, 1, 2, 1, 2. Negative, 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 negative. Now you have labeled your axis. Now what do? You need to just come and represent. Remember, this is the real part, and the real part of the complex number is put on the real axis. So here now the real part is negative 1. So on the real axis here, let us look for negative 1. It is here. On the imaginary part, or on the imaginary axis, on the vertical line, let us look for the coefficient of I. And the coefficient of I here is negative 1. And that negative 1 is here. Then we look for where the negative 1 on the real axis will meet the negative 1 on the imaginary axis. So we draw just a perpendicular dotted line. This is where they are going to meet. This is the point of intersection of negative 1 of the real axis and negative 1 of the imaginary axis. So you draw the straight line from the origin to that point of intersection. After drawing that, then you put an arrow at the top, and then you say this is Z3. My work here, I'm putting the arrow on top of the complex number. You find some of you are putting the arrow to point at the center. No, the center is the initial point of displacement. That is the starting point where the complex number moves away from. So this is the solution to example 1 on the Argand diagram. Make sure you are okay with the Cartesian plane, because here we are using the knowledge of the Cartesian plane only to illustrate complex numbers. So thank you. See you in the next example.